this practical learning module on Revit to CostX integration. In this session, we will learn how to take BIM model information from Revit, convert it into reliable quantities, transfer the information into CostX, develop a BOQ and cost plans, and finally prepare the data for project cost analysis and Power BI reporting. This is not a software demonstration. The objective is to establish a controlled BIM to cost workflow. Let's begin with Revit. Open the G+50 MEP project. Before transferring any information to CostX, our first responsibility is to make sure that the BIM model contains reliable and structured information. The first technical check is project units. Go to manage, then project units. Confirm that the project uses the required measurement standards. Unit consistency is extremely important because an incorrect unit conversion can create significant quantity and cost error. We check the HVAC model, select a duct and verify dimension, length, system, type and level. For estimating purpose, the model must contain sufficient information to produce measurable quantities. Family and type identify the component. Level allows floor-wise analysis. System type identifies the MEP. System diameter and length provide measurement information. A standardized coding structure creates a bridge between BIM, quantity surveying, estimating, and project control. For example, ILEC can represent electrical, HVAC can represent air conditioning, PLB can represent plumbing, and FF can represent fire because they organize the measurement information, create separate groups for electrical, HVAC, plumbing, and firefighting. Within each group, classify the measurable components according to the project estimating solve. This allows the project team to identify unusual quantity patterns, repetitive floor cost, and potential an- anomalies. For a G+15 tower, this becomes particularly valuable because repetitive flows provide a strong benchmark for flow quantity validation. Compare Revit quantities against CostX quantities. If there is a variance, don't simply overwrite the number. Investigate the reason. The difference may be caused by exclusion, duplicate elements, until unit conversion, measurement rules, model revision, or unmodeled work. Rate actual committed cost for cost variance, MEP cost per square feet, system-wise cost, and floor-wise cost. This moves the project from static quantity measurement toward continuous cost intelligence. Analyze validated cost information to identify unusual trends, anomalies, cost, risk, and potential for cost value. However, AI should not independently change the project cost baseline. The correct approach is AI always followed by engineer review and management approval. We start with the Revit BIM model. We validate the model and create structured quantities. We transfer those quantities into CostX. We develop the BOQ rates and cost plan. We validate the quantities and investigate variances. We then connect the control cost information to Power BI for management reporting. Finally, AI can assist with autonomy detection, trend analysis, and cost risk interpretation. The final decision remains with AI, with the responsible engineer and project management. The real value is not simply transferring quantities from one software to another. The real value is creating a traceable connection between BIM information, quantities, BOQ, cost planning, and management decision. In the next stage, we can extend the workflow into automated cost monitoring, change management, Power BI dashboards, and AI assist project cost forecasting. If you are working in BIM, quantity surveying, estimation, project management, construction planning, or project control, this workflow can become an important part of your digital project management system. Complete AI plus BIM workflow from design to digital twin. Follow the Nirgudwar project management consultant AI plus BIM for the project management. Thank you.